Hello everyone, Mr. Fritz here. In this video we are going to talk about functions, so you should have your notes in front of you and follow along with me here. Anything I jot down, consider it part of your notes here. So let's get started. We're going to talk about functions and what they are, what they aren't, but first we should talk about relations. What a relation is in the math world, it's simply a set of pairings of inputs and outputs. So you've seen relations before, maybe we just didn't call them that. Anytime that you have some x values matched up with some y values, you've seen a relation. And it's called a relation because there exists usually some sort of relationship between the input and the output. The input could produce an output for some rule or reason. And in a relation, we have two specific terms that we talk about. We said it's a pairings of inputs and outputs. Well, the domain refers to our inputs. And we also refer to the domain as the set of all possible x values. The range we see is a fancy term for our outputs. And just like the domain is the set of all x values, the range will be the set of all possible y values. Set of all possible y values. Well, you can kind of make sense of that there. So really, like I said, we've seen x's before, we've seen y's before. We might have called them inputs and outputs. So we're just going to attach this new word domain and range. Now I want to point out range, this isn't the same type of range you might have seen before when you're talking about a range of values between your minimum and your maximum. This is a different kind of range. The range is now just all the numbers that are possible in your y values. And sometimes they kind of look like the range that you might have seen before, but we're specifically talking just about y values with this kind of range. So let's see what relations look like. Relations can be expressed in different ways. So next up, we have some examples here. We can talk about a relation verbally. So the domain of a relation is consecutive even integers between -4 and 4. So that means that all my inputs, all my x values in this relation is going to be consecutive even integers between these two numbers. So that's looking like -4, -2, 0, 2, and 4. Those are my consecutive even integers. The range is going to be the relation, the range of this relation is 3 more than the x, where x is a member of the domain. So what we're already seeing here is that the range usually depends on the domain. We talk about x and y values like they're independent and dependent variables, and that's true with the domain and range as well. X would be our independent, and y, or our range, will be our dependent variable. So that's how we could verbally talk about domains and ranges and relations. We can also create a table of values that reflects domains and ranges and a relation as well. So let's take this domain, and traditionally we put our x values on the left side of our table here, so let's fill that out. We'll use this same relation that we already described. We have our set of x values. Our domain is this set of 5 numbers. And our range then is going to be dependent on our domain. And let's go back to the rule here. The range of the relation is 3 more than the x. So what I'm going to do then is I'm going to take this x value, and my range will be 3 more than this. So 3 more than -4 is -1. 3 more than -2 is 1. 3 more than 0 is 3. Then I have 5, and then I have 7. So now we can see that the range is going to be -1, 1, 3, 5, and 7. And that's it. Those are all the possible values in this relation for this given set of numbers here. We can also numerically represent our relation with ordered pairs, just like you would any sort of ordered pairs that could be graphed. So we can turn all of these rows into ordered pairs. And let's do that below. So we have -4, -1. We have -2, 1. We have 0, 3. We have 2, 5. And finally 4, 7. And what you'll often see when you see these ordered pairs is you'll see something called set notation. And we like to put sets inside of these little curly braces here. That just means that we are containing a set of things inside these braces. So that's something you'll start to see. In this same set, or the same relation rather, we could describe the relation graphically by using a map. And the way the map works is it's kind of like the table where we have our x values and our y values, or our domain and our range. We can call these also the inputs and the outputs, all kind of linked together, those terms. And inside of these maps, we have the values for our domain: -4, -2, 0, 2, and 4. And then we also have our range. I'll put that in there as well. And we have -1, 1, 3, 5, and 7. And so right now this is probably looking a lot like the table of values, except all of our numbers are in this oval, these bubbles. But what makes a map different is that we actually show how these inputs produce the outputs. And when we say map, we mean that we are pointing towards a value. Just like a map will point you towards a destination or show you how to get somewhere, this input in our map is going to directly point to an output. So we always connect our arrows from our inputs to our outputs, always from left to right, and always to the output that is produced from the input. So the -4 here is relating to the -1. The -2 is relating to the +1. So that's why we connect the arrows like that. And then finally, we can use these ordered pairs to form a graph, and we can do that just like we would any normal coordinate plane. So we've got -4, -1, -2, 1, 0, 3. Oops. 0, 3. 2, 5. 4, 7. Now, if you're sensing a pattern here, that's because there is a pattern, right? I am taking all of my inputs and I am increasing them by 2, or rather increasing them by 3 to get my output. And that produces a relationship or a pattern or a rule. When we talk about patterns or rules, we talk about equations. You might see even this line shape that's being formed here, and I can write the equation of this line in the y equals mx plus b form, where m is my slope, b is my y-intercept. And if this were a line, my y-intercept is at 3. So right now I have a +3, and it looks like the slope is up 1, or up 2, over 2, up 2, over 2. So looks like I have a slope of 1. So my equation that would describe this relation would be y equals 1x plus 3. But you'll notice, if I were to plot this thing on a graphing calculator or by hand or on Desmos, this would actually create a line, but my domain and my range is just these specific points. So actually, I'm not graphing a line, I'm graphing points given by this rule. So I have to do something to restrict this equation so that I don't produce this line. So what I'm going to say here is that I'm going to say where x equals consecutive even integers from -4 to 4. And that's going to be consistent with the domains and ranges seen from all these other representations. So we're going to take a quick pause here, and I'm going to start up in the next video some more examples of what a function would be to build on top of relations.